Okay, so in this, we are going to be going over problems 1 through 4. So the first problem is design a bandpass amplifier where the gain is -10 and the frequency, the low frequency, is 100 radians per second, and the high frequency is 10 to the fourth hertz radians per second. And the important thing to note is that when we have the formula f sub -3 dB is equal to 1 over 2 pi RC, we're actually looking for omega sub -3 dB, which is going to be equal to 2 pi f sub -3 dB, which means, which is very nice for computationally speaking, we get to multiply that by 2 pi. So we get the formula omega sub -3 dB is equal to 1 over RC. For the low frequency, it's going to be 1 over R1 C1, and for the high frequency, it's going to be 1 over R2 C2. And as established, that is 100, and that is 10 to the fourth. Now we have to determine other stuff. The gain is -10. Because of this, we know the gain as well is negative R2 over R1, which implies that R2 over R1 is 10. We can use this fact to compute what the ratio between C2 and C1 is by dividing 100 by 10 to the fourth, because that will result in R2 and C2 going onto the numerator and R1 and C1 being on the denominator. So we get that 100 over 10 to the fourth is equal to R2 C2 over R1 C1, which we established at R2 over R1 is that's 10. So 100 over 10 to the fourth is equal to 10 C2 over C1, which implies that 10 over 10 to the fourth is equal to C2 over C1, which implies that C1 over C2 is equal to 1,000. Then we have to consider what values can we choose. So let's just do the capacitors first, because those are like defined. Like there are certain values that are like stated, like they're designated values for them. And as we can see, there's 100 picofarads, 1 nanofarad. Michael, please scroll up a bit. And 10 nanofarads, 100 nanofarads. It says 100 nanofarads, 1,000 times 100 picofarads. I'm just going to let C2 be 100 picofarads and C1 be 100 nanofarads. Now R2 is 10 times R1. And I said choose any resistor value, so I decided to choose 500 kiloohms for R2 and 50 kiloohms for R1. Now onward to the second question. Second question is to find the passband gain in decibels. The passband gain in decibel is just 20 times log of the magnitude of the gain. Well, as established in the statement of problem 1, the gain is -10. The magnitude of that is 10. Log of 10 is 1. Therefore, the answer is just 20 dBs. Now, they wanted to ask for the maximum peak-to-peak output voltage given the rail output op amp. Well, the output voltage is limited by the rail output op amp, right? The maximum with the power supplies where the top is 5 volts and the bottom is -5 volts. So all we need to do is do 5 minus -5. That's 10 volts. Therefore, the maximum peak-to-peak output voltage is 10 volts. Then there are 2 formulas we can use for the fourth question to find the RMS output. Firstly, VPP is equal to 2VP. Secondly, VRMS is equal to VPP over root 2, which implies that VRMS is equal to VPP over 2 root 2. And
it's VP over root 2, right?
Yeah, it's VP over root 2. VRMS is VP over root 2, but it's VPP over 2 root 2.
Yes.
So then, using these 2 formulas, we can deduce that the RMS, the maximum sine wave RMS output voltage, is 3.54 volts approximately, because we're dividing by root 2. 3.53553. Just right to the nearest hundredths place is 3.54 volts.
Yep. Thank you for watching.
Thank you indeed.